The James Webb Space Telescope's first deep-field image unveiled thousands of ancient galaxies, galaxies that, according to current theories, shouldn't even exist that early in the universe. This unexpected discovery has left scientists astonished, as a single image has the power to challenge long-held beliefs about the universe's origins. Now, a second deep-field image has been released, and once again, it's revealing strange phenomena that science can't yet explain. These observations are pushing us to reconsider everything we thought we knew about the early cosmos. The James Webb Telescope, JWST for short, is taking us on a remarkable journey through time, reaching back to the universe's infancy. Equipped with groundbreaking technology, it can detect the faintest light signals that have traveled across space for as long as 13.5 billion years. The result? Stunning images that provide a window into the distant past. Even in its first deep image, JWST captured thousands of ancient galaxies, many of which had never been observed before. For the first time ever, we're witnessing galaxies so ancient that no previous telescope has been able to detect them. The James Webb Space Telescope, developed through a collaboration between NASA, ESA, and the Canadian Space Agency, CSA, was specifically designed to uncover the mysteries of the early universe. It launched on December 25, 2021, from the ESA spaceport in French Guiana and took 30 days to reach its orbital destination. Since the summer of 2022, it has been sending back stunning images. Costing around $10 billion, the project has already proven to be worth every cent. The scientific value of its discoveries is beyond imagination, offering insights not just for researchers but for humanity as a whole. Many long-held beliefs about the universe are now being challenged, and our innate curiosity drives us to understand who we are and how everything truly began. Equipped with 18 hexagonal mirror segments, JWST can observe the cosmos with nanometer precision, finer than the width of a human hair. This groundbreaking telescope is now exploring the very edges of the universe, searching for answers hidden in the depths of space. Through the power of infrared light, thousands of galaxies have come into view. Who would have imagined that a relatively small technological advancement could lead to such monumental discoveries? It was a brilliant move by scientists and engineers to equip the James Webb Space Telescope with infrared sensors. Although invisible to the human eye, infrared light is an ideal tool for detecting the universe's oldest light signals. It also has the unique ability to pierce through cosmic dust clouds that often block our view of the early universe. By capturing infrared wavelengths, the James Webb Space Telescope allows us to peer into regions of space that were once hidden, almost like seeing through the cosmos with X-ray vision. One of its first deep-field images unveiled a stunning array of galaxies. The now iconic photograph of the SMACS 0723 galaxy cluster reveals countless galaxies whose light has taken more than 13 billion years to reach us. This image is not only awe-inspiring but also groundbreaking from a scientific perspective. According to the standard cosmological model, the early universe was expected to be mostly empty, with the first galaxies forming only several hundred million years later. Yet, Webb's observations reveal a surprising abundance of galaxies that already existed just a few hundred million years after the Big Bang. These findings challenge long-standing theories. The presence of so many mature galaxies so early in cosmic history could suggest that galaxy formation occurred much faster than previously believed, or even that the universe might be older than we've assumed. Some of these galaxies are far larger and brighter than any current models had anticipated. Simply put, this challenges the accuracy of the standard cosmological model. Rather than observing chaotic gas clouds, scientists are seeing well-formed spiral and elliptical galaxies, structures that typically take billions of years to develop through collisions and mergers. According to the traditional view, the universe began with the Big Bang as a hot, dense mix of energy and particles. Only after the recombination era, when neutral atoms could finally form and the universe became transparent, did matter begin to take shape. The expectation was that order would gradually emerge from this initial chaos over immense spans of time. But now, we're faced with a puzzling question: how can the universe appear so well-structured at such an early stage? Where might previous theories and calculations have gone wrong? One intriguing idea is that what we're seeing might not just be early galaxies, but massive clusters of forming stars, or protostars. Let's explore the scientific theories proposed to explain these impossible galaxies, and consider the extraordinary possibilities that arise when we allow ourselves to question the nature of reality. Some of these objects may appear as galaxies due to the James Webb Space Telescope's extraordinary sensitivity. Additionally, the gravitational pull of massive galaxies can magnify the light from even more distant sources, a phenomenon known as gravitational lensing. Another well-known theory involves starburst galaxies, galaxies that, at certain stages of their development, suddenly generate thousands of stars. This rapid star formation not only accelerates their growth but also contributes to the formation of complex structures. But why is structure so significant, and why are scientists searching for clues about cosmic evolution in the presence of order? Until recently, the prevailing theory held that the Big Bang produced a chaotic, swirling soup of free-floating particles and gas. In such an unstable, high-temperature environment, the emergence of structured matter was thought to be nearly impossible. Atoms and molecular chains, the very building blocks of matter, were believed to have formed only gradually over a long period. This perspective is rooted in the idea that things newly formed in nature tend to be in an unorganized or incomplete state, with order emerging over time. But what if we've been looking at the beginning of the universe all wrong? Instead of emerging from pure chaos, what if the universe was born with structure already in place? Perhaps creation didn't begin with a singularity that unraveled into disorder, but with a fully formed design, an intricate framework from which stars could have emerged much earlier than current science can explain. Consider a rose. It doesn't bloom out of chaos. In fact, nature is full of structured patterns that create, sustain, and recycle life. The same concept could apply to the cosmos. Theories like the brain model and string theory suggest that the universe may be based on an intelligent membrane of ultra-thin threads. Though still unproven, these models are the only ones that currently offer a unified mathematical explanation for both the vastness of space and the subatomic world. Now, with the James Webb Space Telescope, JWST, we're seeing objects that don't fit the rules of classical physics. This strongly suggests that our current scientific framework might have reached its limits, and that it's time to rethink our understanding of the universe. Take the Webb's second deep field image, for example. Once again, astronomers turned the telescope toward a different region of the cosmos, and the results were astonishing. Just like before, we're peering back billions of years in time, uncovering more about the universe's earliest stages. These deep field images are made possible by extremely long exposure times, revealing galaxies and structures that challenge everything we thought we knew. The telescope is aimed at what appears to be an empty patch of sky, capturing the faintest light signals from the most distant objects hidden beyond the seeming void. Over several days, this clever approach proves effective. Without any nearby stars or galaxies to interfere, the telescope can gather the nearly undetectable traces of faraway celestial bodies. These long exposures often last many hours or even days, producing hundreds of images that are later combined into one detailed picture. This method isn't new. Hubble Space Telescope once amazed us with a groundbreaking deep-field image. However, the James Webb Space Telescope takes it even further. Thanks to its ability to see through cosmic dust using infrared technology, Webb produces far sharper images, revealing galaxies that are much older and once invisible to us. There's a fascinating story behind the very first deep field image. Back in 1995, astronomer Robert Williams, then director of the Space Telescope Science Institute, made a bold decision. He proposed pointing Hubble at a completely empty region of space. Many experts thought it was a waste of precious observation time. Why photograph nothing? But Williams was determined. Over 10 days, Hubble captured 342 individual images of this tiny area of the sky, and the results were revolutionary. This region of space represents just a tiny fraction, about 1/24 millionth, of the entire visible sky.